Okay, Assalamualaikum. The second reaction of alcohol, 5.4554 elimination. Your alcohol converted into alkene. Okay, elimination of alcohol, or we call it as dehydration. Maksudnya kita buang air. We eliminate a H2O from an alcohol. So we will look through the reactions involved, the mechanism behind the conversion from alcohol into an alkene. Okay, the first step, elimination of water, dehydration water ni, requires an acidic catalyst, sulfuric acid. Okay, this is a sulfuric acid kan. So kita hanya guna simbol H3O+. Still remember from your acid base, hydronium ion. To protonate. Protonate maksudnya kita tambah. Masukkan hidrogen dalam hidroksi. OH dimasukkan hidrogen lagi dalam dia. So dia ada H2O nanti in a way. Okay, nanti kita tengok. Of the alcohol and convert it to a good living group. So senang kita nak tendang dia keluar. The first reaction. Okay, the first reaction, your double bond lone pair ni akan attack your hydronium sebab dia nak protonate the hydroxyl ni. To protonate the hydroxyl group. So it takes one of the hydrogen from your acid tadi tu untuk attach kepada sini hydroxyl group. So this is the product. So hydroxyl group kamu ni ada plus ion. So ni jadi a good living group ni. The whole thing sebiji sebesar ni. A whole good living group. So dia dah terlalu access kat sini, dia tak boleh dah, so dia akan keluar. So the second step, water leaves. Ni kan water. H2O. H ada dua O. This is a water molecule forming a carbocation. So lepas yang ni keluar, bonding ni pun oksigen akan bawa sekali sebab dia akan form water balik. So ada dua lone pair dekat dia, ni ada satu, so dia akan bonding ni dibawa sekali bila dia keluar. So dekat sini akan lack of electron. That's why your carbon will get a carbocation. So the third step, loss of another proton gives alkene. So hydrogen yang ni pun akan dibuang. So bila hydrogen ni buang, double bond ni, elektron ni, kan sini ada elektron. So elektron ni akan pergi ke sini membentuk double bond. Okay, this is your alkene. So there's a rule on how we want to determine what kind of product will be produced. What kind of alkene will be produced as the product. So acid catalyzed dehydrations usually follow Zeth rule and yield the most stable alkene as the major product. So this reaction will have a major and minor products. The ease of dehydration follows the order. So tertiary, this is the tertiary alcohol. This is your secondary alcohol and this is your primary alcohol. So ikutkan tertiary lebih senang compare dengan secondary daripada primary alcohol. So for your tertiary alcohol, readily dehydrated with acid heat. So simple saja reaction dia. For a secondary alcohol, you need 75% of acid. Sangat kuat ni Suhu 100. Primary 95% acid dengan 150. So dah semakin sukar sebab condition dia semakin harsh. To avoid the need for strong acid H2SO4, POCl3 in pyridine is used to dehydrate secondary and tertiary alcohols at 0 Celsius. Okay, this is the rules that govern your products. Regioselectivity in acid catalyzed dehydration of an alcohol. So a tertiary alcohol will involve with a regioselectivity. So what is a regioselectivity? Okay. Regioselectivity is a positional isomer. So dia akan membentuk positional isomer as the products. Positional isomer tu apa? Bila kamu punya functional group ataupun kamu punya apa tu? Double bond ke, kamu punya functional group ke berubah. Contohnya Br mungkin boleh jadi 1 Br, 2 Br, 3 Br. That is a positional isomers. Okay, for this example, we have 2 methyl, 2 butanol. So ni, OH ada dekat attachment kat sini. So dia ada 1 jiran, 2 jiran, 3 jiran. So this is a tertiary alcohol. So when it dissolve in acid with the heat, so alcohol ni boleh convert menjadi alkene. So there are two products will form, 2-methyl 2-butane ataupun 2-methyl butane. So bezanya dekat mana? Beza dia ni. The double bond is at a different position. So this is why we call it as a positional isomers. There is a rule, okay? Nanti kita akan tengok. Okay. Stereoselectivity. Tadi regio, ini stereo pula. Apa kejadahnya ni? So stereoselectivity is when the isomer is in form of a cis dengan trans. So it involves primary and secondary alcohol. So primary and secondary alcohol, bila dia convert jadi alkene, there's a possibility to form a cis and trans isomer. Okay, so this is the example of your alcohol. So this is your C, this is one C, this is the second C. So this is the secondary alcohol. React with acid with heat, so dia boleh convert menjadi cis 2-pentene as a minor product ataupun trans 2-pentene as a major. So this is a cis, this is a trans. Same compound 2-pentene but at different stereoisomer. Okay, dia cakap elimination of 3-pentanol ni 3-pentanol yields trans and cis 2-pentene. Trans 2-pentene is more stable. Isoisomer predominates. So a trans will be your major compound. Okay, this is the rule that governs this reaction. Side-Zeff rule. Okay, for elimination reaction that produces more than one alkenes, the alkene with more than one alkyl substituents in the double bond is the predominant product. Okay, so contohnya 2-pentanol. So this is a secondary alcohol. So bila secondary, dia akan membentuk stereo isomer. So there will be a cis dengan trans kat sini nanti. So kat sini OH. Sini ada H. Okay. Sini ada 3 H kat sini. H, H, H. Okay. Bila kita nak, ni ada 2 H. Sorry. Ni ada 2 H. Okay. Elimination reaction is a dehydration, meaning you want to get rid of water molecule in your alcohol. So the possibility for water to be be eliminated antara OH ni ataupun H ni dengan H ni, dengan H ni dengan H ni. So H mana dia akan buang? H yang warna biru ataupun H warna merah yang akan dia buang untuk eliminate water. So dalam Side-Zeff rule dia cakap more alkyl substituent is predominant. So katakanlah kita buang hydrogen warna biru. Okay, alkyl group. This is an alkyl group. Tengok kiri kanan yang H nya nak dibuang. So kiri kanan H yang warna biru ni is not an alkyl group. H warna merah ni, this is an alkyl group. So Zaf cakap selamatkan alkyl group. Jangan kacau alkyl group sebab alkyl group ni akan menjadi major. So dengan membuang hidrogen yang biru ni, kamu telah menyelamatkan alkyl group yang ni. So alkene with an alkyl group will be your major, tapi bila kamu buang hidrogen dekat sini, double bond akan ada dekat sini, this will be your minor product. Sorry. If you eliminate this hydrogen, which means you save this alkyl group. So double bond dekat sini ialah major. So ini. Pada dua pentin ialah major. Tapi kalau katakan kamu buang hidrogen yang ini, maksudnya kamu dah kacau alkyl group, menyebabkan ini akan jadi major bila double bond berada di position yang pertama. Okay, checkpoint, please do. Your checkpoint, we will discuss the answer later on. Okay, that is for your reaction mechanism on how you want to determine your major and minor product. Okay, satu lagi. Ada lagi bezanya. Okay, rearrangement in acid dehydration of an alcohol, hydride shift. Okay, if you forgot about this hydride shift, so you can refer back to this note 537, rearrangement of an alkene. So the same concept. Okay, with primary alcohols, rearrangement of the products always occurs to form more stable carbocations. Okay, 1-butanol, dia cakap primary alcohol. So primary alcohol, dia kena berubah tempat untuk menjadi secondary, which is more stable. Okay, stability of your carbocation is tertiary is more stable compared to your secondary compared to your primary carbocation. So if you have a primary carbocation and if there's a possibility for it to change into a secondary carbocation, so dia akan membuat hydride shift sebab compound secondary carbocation is more stable. Okay, for example, 1-butanol, which is your primary alcohol, undergoes dehydration with rearrangement to give a mixture of 1-butene and 2-butene. Primary carbocation form and hydride shift occurs to form more stable secondary carbocation. So contohnya kat sini. Okay, cuba buka expand dia. 1, 2, 3, 4. Okay, OH ada dekat sini. H. Okay, your objective is to eliminate a water molecule. So there is no other option. OH ni akan keluar. Satu lagi H akan diambil daripada karbon sebelah ni. Dia tak boleh ambil karbon yang sama. Bukan kat diri dia, kena ambil kat jiran. So these 3 atom will leave the alcohol to make a double bond here. Okay. So dia akan jadi dapat 1 butene. Betul. As a product. We thought this is the only product sebab ada satu possibility sahaja hydrogen untuk dibuang. Sebab dia tak ada alkyl group pun yang dia nak kacau kat sini. Okay. But the thing is, 1-butene is not your major product. This is your major product. So how come double bond ni boleh beranjak pergi ke position yang kedua? Because of the hydride shift. Okay, we will see the mechanism. Rearrangement in alcohol. Okay, hydride shift. So contoh yang sama, still juga. So kita assume double bond tu sepatutnya ini OH kan. So dia akan eliminate. So H kat sini pun akan dibuang satu. So double bond akan berada di sini. So we assume that we'll get only one product as 1-butene. But However, it produce two products, one butene and two butene. So kita ingat one butene tadi memang major, memang dia saja. Tapi tengok one butene is a minor, two butene is a major. How come? What happened? What actually happened during this reaction? Okay, we'll go through the reactions. Reaction dia sama 4 steps tadi, macam yang awal-awal tadi. So, first reaction, first step dia ialah water. Acid ni akan, OH ni akan diprotonate. So, dia akan ambil, lone pair ni akan serang hydrogen ni untuk diprotonate the hydroxyl group sini. So, hydroxyl will have an extra hydrogen, make it a positive. So, make it this whole thing as a good leaving group. So, senang kita nak buang dia. So, lepas dah buang dia ni, dia akan menjadi carbocation sebab dia dah leftkan benda ni kan, so dia akan jadi carbocation. So this is your primary carbocation. Okay, sebelum tu so possibility untuk dia menjadi produk ialah dehydration. Kita assume dia akan buang OH ni dengan H ni kan, H biru. So H merah ni tak diganggu sebab jauh kan. So we assume that we will produce a double bond here. Okay. So this is your primary carbocation. Okay. Primary carbocation is not stable one. So in this compound, in 1-butanol, there's a possibility for the carbocation to be shifted untuk menghasilkan secondary carbocation, which is more stable compared to your primary. So this is your primary carbocation. So let's say lah hydrogen dia nak bertukar tempat dengan carbocation. So kat sini dia ialah primary. Ni ialah primary carbocation sebab C ni attach dengan satu C saja. Berjiran dengan satu C yang lain. Tapi katakanlah carbocation ni berpindah kepada carbon yang kedua. So when this positive ion shift into the second carbon, so carbocation ni akan jadi secondary carbocation, which is more stable compared to your primary. So dia rearrangekan diri dia menjadi secondary carbocation, baru dia akan proceed dengan reaction yang berikutnya. Okay, this is your secondary carbocation. This is your primary carbocation. Still ada dua-dua. Dua-dua reaction masih boleh berlaku. So this is your secondary. We look at your secondary carbocation. So the first, the final step after that, hydrogen akan diserang, water akan ambil hydrogen yang ni. So bila hydrogen dah ambil, dia akan buat bonding dengan lone pair oksigen ni. So, dua elektron kat sini yang left ni akan di double bondkan kat carbon dengan carbon. So, kamu akan dapat two butene dekat sini. Ni carbon satu, ni carbon dua. So, you will get a 2 butene as your product. Okay. As this is originally a primary alcohol. So primary alcohol akan membentuk stereo isomer. So produk dia akan membentuk stereoisomer, either a cis or a trans. So kat sini dia akan membentuk dua-dua cis trans. Tapi trans will be the most stable one. So you will have a 2 butene as your major product kat sini. Major product for a second major. For a secondary carbocation product. Okay. At the same time, your primary carbocation masih ada. So carbocation kamu dekat sini akan mengalami apa? Okay, so dia akan buang satu hydrogen ni. Hydrogen biru ni akan, okay, ni tak ada arrow Tak ada arrow kat sini. So, dia tak akan buat shifted kan? Dia tak akan buat rearrangement of your carbon ion. So hidrogen ni akan blur, elektron kat sini akan buat double bond dekat situ. So ini water akan extract hydrogen from your alkene. So the electron kat sini akan jadi double bond. So it will produce a 1 butene as a minor product. So secondary akan menghasilkan major product, which is your 2 butene. Your primary will produce a minor product, which is your 1 butene. Okay, do your checkpoint.